Hey, all right, so today we're going to talk a little bit more about units. And to start off, I don't know if you've ever played Mad Libs before, but here's a little Mad Lib for us to look at. So, we'll call this a math Mad Lib. There were five that traveled 30. It took 25. They stopped and rested for 6 before returning. Okay, and you might be thinking, well, that doesn't make a ton of sense because we don't really understand what's going on. Clearly, something went somewhere and then came back. And you might have in your mind, oh, well, this was probably people. Maybe this was miles. You might have something in your mind, but we have no idea. And the numbers or the units that we attach to these numbers give it a lot of meaning, okay? Because let's say, because these don't necessarily have to be people, they could be elephants, okay? And maybe the elephants traveled 30 minutes. Well, let's say they traveled for 30 days, okay? And that would be, this one is a distance, looking at the context. So maybe they traveled 30 kilometers, and maybe it took them 25 days, and maybe they rested for 6 months before returning. Okay, so I mean, and who knows if that is even a realistic scenario, but you can see that the units give some context to what's going on, because we could rewrite this in a completely different way. Because maybe these are some kind of bird, maybe they're like ducks, and they traveled 30 I don't know. I guess we're kind of limited to distance measurements. We don't have that large of distance. We'll say they traveled 30 miles, and let's say it took them 25 hours. It probably doesn't take a duck that long to travel 30 miles, but they stopped and they rested for 6 minutes before returning. Okay, so I mean, you can go wild here with your imagination and think of scenarios that make sense, and hopefully, I mean, really the idea I'm trying to get across here is that these units are really important to give context, okay, and they give meaning. And saying that this distance is 30 miles gives a lot different meaning than saying maybe that it was 30 inches, right? Or if it was like 30 meters, okay? Those scenarios would be very different. And so it's important for us to give some context to this, okay? And that context helps us understand what's going on, like what this number represents relative to these other things, okay? Talking about the system measurements that we're going to use in class, and that really it just makes a lot more sense when we're talking about doing science. And so we're going to be looking at the metric system, and I'm just going to talk about a couple of the units that we really need to be familiar with, and a couple of the conversions that we need to really be familiar with. So the base units, we're going to be working a lot with meters for distance, and when we talk about mass, we'll be using kilograms, okay? Now these are two there's a important difference between these two units, okay? Because meters are a base unit in that you can attach a metric prefix to meters to change the what you're measuring, okay? In kilograms, you see that prefix is already attached, okay? And the metric prefix is 1,000. Kilo represents 1,000, okay? Which means that this is saying 1,000 grams, okay? So let's say if you had 2 kilograms, okay, what you're saying is you have 2 sets of 1,000 grams, okay? Or that would be the equivalent of 2,000 grams, okay? Now, the standard unit for mass is actually kilograms, okay? Because, well, why do you think that might be? So a gram has the mass of about a paper clip, whereas a kilogram is more about the mass of like your physics textbook. Okay, so why do you think that we would use kilograms as a standard unit for mass as opposed to grams? Well, it might be because kilograms are more kind of aligned to what we deal with every day. So we don't, I mean, it's difficult to talk about things as small as paper clips. Kilograms are more something representative to our daily experience. So, you know, you have a bottle of water has a mass of probably like a half kilogram, and you have maybe your textbook is like maybe a kilogram, maybe your backpack is 3 kilograms. Um, and so it makes more sense to talk about it like that as opposed to saying your backpack has a mass of 3,000 kilograms or 3,000 grams. Okay? And so when we talk about the metric system, the thing that we need to be able to do is use these prefixes to go between measurements, to convert between different metric measurements. Okay, so some kind of the way it works. Let me go ahead and bring up a picture of it. So I've written down some of these metric prefixes that are nearer to the base unit. So the base unit is going to be meters, going to be grams, going to be liters, okay, depending on what we're measuring. And there's other units too that this works for. And so if you were to look at a decimeter, it would be 10 to the negative first the size of a meter. Okay, that would be the tenth of a size of a meter. A centimeter is 1/100th the size of a meter. A millimeter is 1,000th the size of a meter. Whereas a decameter would be the size of 10 meters. Okay, a heptameter would be the size of 100 meters, and a kilometer would be the size of, 1,000 meters. Okay, and so the trick here is this. When we're doing metric conversions, when you're swapping these prefixes, you basically have to look at which way you're going. So if I want to take meters and find out how many millimeters they are, I'm going to go from here to here. Okay, and so what I have to do is I have to take my number and divide by this, basically the number that we're going over. So if we're going this way, it's negative, this way it's positive, so we're going 1, 2, 3. So we're going to divide it by 10 to the negative third. So if we have 3 meters, we divide it by, we multiply it. Yeah, so we divide it by 10 to the negative third. Okay. And that's going to give us 3,000 millimeters when we divide. Okay? So let's say if we wanted to find out how many kilometers was 5 centimeters, if we want to convert that to kilometers, okay? Before we even do any converting, let's just think about it for a second. 5 centimeters. What's something that's about 5 centimeters? Maybe the width of the screen on your phone. Okay, think of kilometers. What's something that's 5 kilometers? Maybe the distance from here to maybe a certain store or something, or to the mall. Okay, and so clearly a kilometer is much bigger than a centimeter. So 5 centimeters is going to be a very small amount of kilometers. Okay, so to get from centimeters to kilometers, that's a jump of 1, 2, 3, 4, 5 places. So we're going to divide it by 10. This way is positive, so we're divided by 10 to the 5th. Okay, and 5 divided by 10 to the 5th would be 0.00005 kilometers, okay, which makes sense because a centimeter is not very many kilometers, okay? And as you get used to the metric conversions, you don't need to do it the way that I am. I personally, for me personally, when I'm doing metric conversions, I just think of the relative size of the things and the number of steps between them, and I move the decimal place. So, for example, I know that 15 grams is much, much smaller than 15 kilograms. So this would be some fraction of a kilogram, okay? So it's 3 spots away, so I'm going to move that decimal 3 spots. So 123.015 kilograms. Okay, so I'm actually going to have you do a couple of conversions. Go ahead and convert 13 liters to milliliters. Okay, and you should have gotten that 13 liters is about 13,000 milliliters. Okay, go ahead and also convert, let's say 32 centimeters. I want you to convert that to heptameters, okay, which I've never even used the prefix hepta, but go ahead and give it a try. All right, so you moved over 1, 2, 3, 4 places. We're going to move that decimal place 4 places. So that's going to be 0.0032 heptameters. Okay? And pretty much the prefixes that I want you to be familiar with are kilo, centi, and milli. Okay? Aside from those, we probably won't be really using any of the other ones. Okay, so these ones are important to kind of get memorized so you're comfortable with them. And when you're memorizing them, don't just memorize, but think about what they represent. So think about what a kilometer is versus a centimeter versus a millimeter. Okay? And in addition, the other ones you might see are occasionally we're going to run into nano, which is a scale of 10 to the negative 9th. And micro, which is a scale of 10 to the negative 6th. The symbol for micro is this little Greek U, okay? And the symbol for nano is just N, okay? Also, a micrometer is a millionth of a meter. A nanometer is a billionth of a meter. Okay?